This is part 3 of solving quadratic equations using the square root property. Now, just as a quick review, let's review a problem from a previous lesson. Suppose we had that we want to solve this quadratic equation, x plus 2 squared equal a negative 8. Now remember, you want to use the square root property when the quadratic equation looks like this. So you have some expression involving the variable squared equals some number. So when it looks like this, which this does, you have some expression squared equal a number, and the coefficient in front of this is a 1, then we can use the square root property. And the square root property basically says this: suppose I had x squared equal b. Now, we saw in a previous lesson that let's assume that b is positive, that there's a positive x value and a negative x value, so that when I square it, I get b. So you have two solutions. You have a positive and a negative. And so when we took the square root of both sides, because right now I'm squaring x, and the opposite of squaring is to take the square root. So when we took the square root of both sides, we remember that, or you should remember, that you need to take the plus or minus square root. And so the square and the square root undo each other, so you get x equal plus or minus the square root of b. Alright, so that's the idea we're going to use here. So in this case, when I take the square root of both sides, I'm going to go ahead and rewrite this over. So when I take the square root of both sides, just like this, and don't forget a plus or minus, the square and the square root undo each other, so you get x plus 2 equal plus or minus. Now remember, you're taking the square root of a negative 8, and recall that the imaginary unit, which is I, and is defined as the square root of negative 1. So the square root of negative 8, and you could have done that in your head, the square root of negative 8 is the same as the square root of negative 1 times 8, which is the square root of negative 1 times the square root of 8, and square root of negative 1 is I. And then we would simplify the square root of 8. So remember, the square root of 8, we want to use the largest perfect square that goes in the radicand. Now you don't have to use the largest perfect square. You can use a perfect square other than 1, but to simplify it will take you more steps. So it's always easier to use the largest perfect square, and so that's what I'm going to use. So the largest perfect square that goes into 8 is 4. So I'm going to write this as square root of 4 times 2. And remember that basically in your mind you really have this mathematically. You have I times the square root of 4 times the square root of 2, and the square root of 4 we know is 2. So this is 2I square root of 2. And so that's this right here, 2I square root of 2. Alright, and then finally get x by itself. You're going to subtract 2 from both sides. And so combine like terms, 2 and a negative 2 is 0. So you get x equal negative 2 plus or minus 2I square root of 2. And so that will be your answer. Alright, so negative 2 plus or minus 2I square root of 2. Now, in reality, you have two solutions. So remember, your solutions are, so you can leave it like this in this compact form, plus or minus, or you can write it as x equal negative 2 plus 2I square root of 2, and the other one is x equal negative 2 minus 2I square root of 2. Okay, so either one of those is fine, either this one or this one. Alright, now what we're going to look at next in part 3 is this idea. So suppose you had this will be, let's go ahead and write this as number 1. Well, let's leave it as this. Okay, so solve. Alright, number 1. Alright, suppose we had 2x minus 3 squared, 2x minus 3 squared equal, let's say, negative 16. Alright, now, the difference between this one and the one we did a while ago is if you look at what was inside the parentheses, the base here, the coefficient of x was 1. Here, the coefficient of x is not 1. So that's going to be the only difference. Everything else will be the same. Alright, so I want to solve this quadratic equation. Notice it is of the form an expression squared equal a number. So I can go directly to taking the square root of both sides. So I'm going to write this over. 2x minus 3 squared equal negative 16. So when I take the square root of both sides and do that plus or minus, the square and the square root undo each other, so you get 2x minus 3, that's 16 right here, equals plus or minus 4i. That's what you get. Then adding 3 to both sides and combining like terms, I get 2x equal 3 plus or minus 4i. Alright, now this looks very similar to what we did here, except now, in the previous problem right here, you had x by itself when you subtracted 2. Here, though, you don't have x by itself, but you have 2x. So now the next step is to go ahead, since I'm multiplying by 2, the opposite is to divide by 2. So let's divide both sides by 2, just like this, and you get x equal 3 plus or minus 4i over 2. Alright, now you can leave your answer like this, that is correct, but keep in mind that there are really two distinct solutions. But this is this is in compact form. So another way of writing it is this. So you can write it as 3 divided by 2, just like this, 3 divided by 2, plus or minus, and then 4 divided by 2 is 2, so you get plus or minus 2i. So that's another way. Alright, all these are correct. Mathematically, they're correct. 3 divided by 2, plus or minus. 4 divided by 2 is 2, so that's where we get this 2, and I get 2i. And if you want to write them separately, you would say x equal, that should be x equal right here. You should say x equal, and there are other ways of doing this one as well. So you can say 3 plus 4i over 2, and the other one is 3 minus 4i over 2, just like that. Okay. Or you could say, taking this right here, you could say x equal 3 halves plus 2i, or 3 halves minus 2i. So all of those are ways of writing the answer, the solutions. All right, now many times what you'll see it written like this, but either one's fine. Either one is fine. Okay. All right, let's look at another one. Okay, number 2. Suppose we had 3x plus 1 squared equal, and let's say I wanted to solve for 28. Alright, well, it is of the forms an expression squared equal a number, so I can take the square root of both sides. So 3x, I'm just going to go ahead and rewrite this over. Okay, take the square root of both sides. Don't forget that plus or minus. And then the square and the square root undo each other. So you get 3x minus 1 equal, plus or minus. Now let's go ahead and simplify the square root of 28. So the perfect square, the largest perfect square that goes in 28 is 4. So I'm going to get the square root of 4 times 7, which is the square root of 4 times the square root of 7. And the square root of 4 is 2. So you get 2 square root of 7. Alright, so the directions will say to simplify. So don't leave your answer like this. If it says simplify, you simplify. Alright, so I get plus or minus 2 square root of 7. And then we're going to bring the 1 over, so I'm going to add 1 to both sides. Combine like terms. This is 0. So I get 3x equal 1 plus or minus 2 square root of 7. Just like this. And then finally, just like we did a while ago, you're going to divide both sides by, in this case, 3. So I'm going to go ahead and rewrite this over. Divide by 3. Divide by 3. 3 divided by 3 is 1. 1 times x is x. And there's your answer. 1 plus or minus 2 square root of 7 over 3. And again, you can write it in all these multiple ways. It's up to you. So you can say, or x equal 1/3. 1 divided by 3 plus or minus 2 square root of 7 divided by 3. Alright, or you can write them as two separate solutions. So you can say x equal 1 plus 2 square root of 7 over 3. And the other one would be 1 minus 2 square root of 7 over 3. So all different ways of writing the solution. But notice how it looks. Alright, now let's go back and talk about rational, irrational. So we're talking about real numbers here. So this right here is the solutions here are irrational because you still had a square root in the answer. All right, so that would be an irrational solution, and look how it's written. So it's written in this compact form. Okay. All right. So let's do one where the solution is, let's say, rational. All right. So let's talk about rational. Now, when we talk about rational and irrational, keep in mind we talk about rational and irrational, we're talking about specifically real numbers. All right, not complex numbers, just real numbers. Not all complex numbers. See right here, that's not a real number. That's a complex number. So we can't talk about rational versus irrational. But that's, in this particular case, that's how this looks. You can't combine like terms. But in the next problem, let's suppose we had a positive square root of 16. Let's see what happens. I'm going to do the same kind here. I'm going to rewrite this whole thing, except instead of negative 16, let's use positive 16. So in other words, let's say we had this. And then compare the two. Make sure you understand the difference between the two, how the solutions look. So suppose we had 2x minus 3 squared equal a positive 16 instead. A while ago, number 1, we had a, right here, we had a negative 16. Alright, so it's of the form an expression squared equal a number, so I can go directly to the square root, taking the square root of both sides. I'm going to go ahead and rewrite this over. Alright, square root of both sides plus or minus, just like this. And so I get the square and the square root into each other, so I get 2x minus 3 equal plus or minus 4. Okay? Now, there are several ways you can do this. You can notice that this is now going to be a rational number because you don't have a square root anymore. Okay? So it's going to be a rational number. So there are two ways you could do this. You can do it just like we did here, where you added 3 to both sides. Nothing wrong with that. You can still do that. Nothing wrong. When you combine like terms, that's a 0 right here. A negative 3 and a positive 3 is 0. So I get 2x equal 3 plus or minus 4. Alright, divide both sides by 2, just like you did a while ago. Nothing wrong with that. I get 2 divided by 2 is 1. 1 times x is x. And I get x is 3 plus or minus 4 over 2. Now, here's the difference. Here, when I did this, I stopped. Alright? Because these were not like terms anymore. 3 plus 4i, I can't say that's 7i. 3i plus 4i is 7i. But 3 and 4i are not like terms, so I cannot combine them. So I can leave them like this. When I did number 2, listen to what I'm saying. When I did number 2, right here, when I did number 2, 1 and 2 squared root of 7 are not like terms. I cannot combine them. Don't say 1 plus 2 squared root of 7 is 3 squared root of 7. That is not true. 1 plus 2 squared root of 7 does not equal 3 squared root of 7. 1 squared root of 7 plus 2 squared root of 7 equals 3 squared root of 7. Notice, when you're dealing with radicals, they're like terms only if they have the same radical with the radicand, the same index with the radicand. Okay, and all you do is just add their coefficients. So notice the difference. So these are not like terms. So they see how it's written? We write it like this. Whereas over here, 3 plus 4 are like terms. You know that 3 plus 4 is 7. So what you want to do is kind of split them up like this. You're going to say 3 plus 4 over 2, and then 3 minus 4 over 2. And so 3 plus 4 is 7, so you get 7 halves as one of your solutions. And the other one, 3 minus 4 is a negative 1, so negative 1 half is the other. And so your solutions would be x equal 7 halves, comma, negative 1 half. So notice the difference between those. It's very important. All right, and let's look at number 4. All right, number 4, suppose we had 4x minus 3 squared equal a negative, let's say 32. So 4x minus 3 squared equals a negative 32. Okay, so it is of that particular form, an expression squared equal a number, so I can go ahead and take the square root of both sides. So I'm going to go ahead and rewrite this. I'm going to take the square root of both sides. Don't forget the plus or minus. The square and the square root undo each other. So I get 4x minus 3 equal plus or minus. And then let's go ahead and figure out what this is. Okay, now keep in mind I'm taking the square root of a negative 32, a negative number. Right here, negative number. So we're going to get an I. We can get that imaginary unit. So that's the same thing as saying square root of negative 1 times 32. And the square root of a negative 1 is that I. So you get I square root of 32. Now, there are several perfect squares going to 32, but the largest is going to be 16. So let's use 16. So you get I square root of 16 times 2. And the square root of 16, remember, is 4. So I get 4I square root of 2. So that's what goes here. So I get plus or minus 4I square root of 2. And then all you do now is add 3 to both sides. Combine like terms. These I can combine. I can't do anything with this, so just rewrite it. So I get 3 plus or minus 4I square root of 2. And then finally, to get x by itself, you divide both sides by 4. So I'm going to go ahead and rewrite this. 3 plus or minus 4I square root of 2. So divide by 4. Divide by 4. 4 divided by 4 is 1. 1 times x is x. So I get 3 plus or minus 4I square root of 2 all over 4. All right, so there's your answer there. Now, don't make the mistake and reduce these 4's, because if you do, and you say 1 divided by 1, you got to remember that 3 is also be divided by 4, so you got to be careful. All right, so don't reduce these if you write it like this. Now, let me say this though: if you write it like this, 3 over 4 plus or minus 4I square root of 2 over 4, then you can reduce this. So that's the difference. If you break it into fractions, then you can reduce this, but you can't reduce it if you leave it as one fraction, because here's the situation. This is not true. Here's the situation. Let me show you. So if you do this wrong, so you kind of do this, see, that's wrong. So what you end up with, you're going to say is 3 plus or minus I square root of 2, but that's not true. That's not true because 3 is also being divided by 4. All right, so that's wrong. So don't divide the 4's. Okay. All right. Now here you can, because you wrote it as two fractions. So that you can. So this becomes 3/4 plus or minus I square root of 2. All right, which is equivalent to this one. But just go ahead and leave it like this. Leave your answer like this. All right. Now notice that these are not like terms. See how this has an I and a square root of 2 and this does not? You can't combine them, so leave them alone. Now also keep in mind this is not a real number because this is an imaginary unit right here. This is a complex number. Okay. All right. So let's look at one more, and then we'll be done with this lesson. Okay. So suppose we had 3x plus 5 squared equal a negative, and let's say we wanted 72, a negative 72. That was equal to a negative 72. So if I take the square root of both sides, because it's already in that form, an expression squared equal a number. So if I take the square root of both sides, just like this, plus or minus, the square and the square root undo each other. So I get 3x plus 5 equal plus or minus. Again, let's deal with the square root of negative 72. So remember, the square root of negative 72 is the same thing as saying negative 1 times the square root of negative 1 times 72. The square root of negative 1 is I, so you get I square root of 72. And 36 is the largest perfect square that goes into 72. So you get I square root of 36 times 2. And the square root of 36 we know is 6. So I get 6I square root of 2. And that goes here. So 6I square root of 2. And then now we're going to get x by itself, so I'm subtract 5 from both sides. subtract 5 just like this, and combine like terms. 5 and a negative 5 is 0, so I get 3x equals negative 5 plus or minus 6I squared root of 2. And then finally get x by itself. You're going to divide both sides by 3. So divide both sides by 3, just like this. 3 divided by 3 is 1, so I get x equal negative 5 plus or minus 6I squared root of 2 all over 3. And there's your answer. There, keep in mind that's two solutions. So if you wanted to rewrite your two solutions as, if you want to rewrite them as two separate solutions, you can. You would say x equal negative 5 plus 6I squared root of 2 over 3. And the other one is negative 5 minus 6I squared root of 2 over 3. All right. Now, again, just like we talked about in this problem, don't make the mistake. Don't make the mistake and reduce these 4's like this. So don't make the mistake and say 3 into 3 is 1, 3 into 6 is 2. You can't do that because 3 is also be divided by dividing into negative 5. Now, if you wrote it as two separate fractions, you can in that case. So you can write it like this: x equal negative 5 thirds plus or minus 6I squared root of 2 over 3, and then you reduce, just like this. And so you could get the answer being negative 5 thirds plus or minus 2I squared root of 2. So that's another way of writing your solutions. So there are multiple ways. You can write it as two separate solutions like this. You could write it as two separate fractions, reduced like this. If you wanted to, you could have said negative 5 thirds plus or minus 6I squared root of 2 over 3 without reducing this. Everything is fine. Okay, all these are the same thing. All these are solutions. There's different ways of writing the solution. Okay, so that takes care of the square root property.